let's go through Leak 1539 case missing positive number. So for this question, it gives us an integer array, and all of these number in array are positive. And let's try to find the case missing number. For example, this array is 2, 3, 4, 7, 11. So first missing one is 1, and the second missing one is 5, and the third is 6, and the fourth is 8, and the fifth is 9. So let's return 9. So of course we can say that this is strictly increasing. If it is strictly increasing, if we iterate from left to right, it will be, and use a counter, it will be O n time complexity. But we can do better. So we can do binary search. So for this question, what we are going to search is that we are trying to write let's first have a function fi equals array I minus 1 minus I. So let's take a look at this one. So this is from array from positive 1, right? So it start minus 1, right? And minus I. This is index. So this formula represents how many positive missing. How many positive number missing before index I. And I is included, right? So for example, this is 2, right? 2 minus 1 minus 0 means there have 1 missing. And let's look at index 3, right? This also have 1. This have 1. And this index is 3, right? So 7 minus 1 minus 3 has 3, right? That means at this index, there are 3 numbers missing, right? So we know this kind of formula, fi equals array I minus 1 minus I, meaning how many positive numbers has missing before this number I. So what we want to search is binary search the last index, which has index has a missing count. Has a missing count smaller than k, right? So what we are searching is the last index, which has a missing count smaller than k. So this will always can find the result, right? So what we do is that we have an int start index as 0 and end equals n minus 1, right? So n equals array.length. So it is always possible we find a index which has a count smaller than k, right? Even for example, when we search in the end, we find the index is the last index, it's still that has a possibility. The 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 so on the right hand, right, it will always have a have a index solutions. But on the left, it is possible. For example, when we search in the end, we have a start here, but this doesn't fulfill the condition that the missing counts are smaller than k. That means we need to check this, right? So that means it is possible the counts before start has already greater equal to k, right? So what we need is that we need to check three conditions. If the because we are after using our binary search formula is that we have start plus one smaller than end, right? And then in the end, why we took coming out of the while loop, we have start one index before end. So we check the end is the last index has missing counts smaller than k. Then we check if the start is the last index which has missing counts smaller than k, right? And the rest condition is even the start doesn't fulfill the condition, right? So let's write the code. So we'll say while this kind of start plus one smaller than end. So we'll say int mid equals start plus end minus start divided by 2, right? So we'll say if let's use this formula, right? Array mid minus 1 minus mid is smaller than k, right? So that means we still need to search because we want to find the last index, which is smaller or equal to k, right? So we still need to search on the right end. We have start equals end mid. Otherwise, we have end equals mid, right? So when jumping out of this while loop, if there is counts smaller equal to k, right? Start or end, either one meets the condition. Then we do something, right? So we'll check because we want to search the last. If array end minus use this function, right? Minus one minus n smaller than k. So that means we search the index is the end. So what we need to return? This is the number already missing, right? At the index end. So we'll say if end, because this is the last index, right? If there is some more index after end, for example, end plus one, right? That will be if we go to array end plus one, it will have the counts greater equal to k already, right? So that means the missing is array end plus something, right? So plus what? We already missed this number. So we should plus k minus this, right? So what is this? This is actually we need to return k plus n plus 1, right? And we'll write if array start minus 1 minus n is smaller than k, right? So that means we search the last index is at the start index. Then we already missing at the index start, we're missing this, right? So we need from array start to add k minus the previous part. So the thing means that we return k plus start plus 1, right? So the thing is that the rest that that is why we should still has if, right? Because it is possible the start already has counts greater equal to k. In this case, we just return k, right? So this will be the code. This start, sorry. So doing like this, the time complexity will be O log n. And we can also write a Python code for this. So we'll say n equals length array, right? And we have start equals 0 and equals n minus 1. What we are going to search is we know the function fi is array I minus 1 means how many number missing at index 1, right? Index I. So we are binary search the last index which has integer has count missing count smaller than k, right? It is possible that start does not fulfill the condition, right? So we need to check both end and start. So what we do is while start plus 1 smaller than end, then we'll have mid equals for Python, we can just have start plus end divided by 2, right? Then we'll say if array mid minus 1 minus mid smaller than k, right? So we just consider this is a function, right? Count how many missing. Then we'll have start equals mid, else we'll have end equals mid, right? So in the end, we check if the end index, if array end minus 1 minus end is smaller than k, right? Then what we return is actually return this, right? Return array end plus k minus, because we missing we already missing this part, right? You're already missing this part. We still need to count k minus this part, right? And this end, if it is the last index, right, we can just add directly. If there is index, for example, index plus 1, right? Index plus 1, the counts already being greater equal to k, right? So we can also use that and plus this one, right? So that means so what we return is k plus and plus 1, right? And then we also need to check if array start minus 1 minus start smaller than k will return k plus start plus 1, right? So if even index I already have the counts missing counts greater equal to k, we just return k, right?